Hello, my name is Shanae Thomas, and I will be conducting a presentation on chi-square tests of independence. This is for the GRC 605 Business Research Methodology and Quantitative Stats course. The agenda for this presentation is to explain the results of the chi-square tests of independence that were both significant and not significant using the APA format. Then I will discuss the takeaways and provide time for any questions. You should use the chi-square test of independence when you have two nominal variables, each with two or more possible values. In the following examples, I want you to keep in mind that the rejection rule for them is that we reject the null hypothesis when p is less than alpha and alpha is equal to 0.05. And we fail to reject the null hypothesis when p is greater than alpha. If we reject the null hypothesis, then we have to have a Cramer's V as well. Chi-square tests let us know if there is a relationship between the variables, and a Cramer's V will tell us how strong the relationship is if there is one. In this example, there was no significant result found between the two variables num_cars and num_defaults. The following correlational test was conducted. The null hypothesis was there is no relationship between num_cars and num_defaults. And the alternative hypothesis was there is a relationship between num_cars and num_defaults. The chi-square statistic and its p-value were calculated using PSPP, assuming that alpha was equal to 0.05. No relationship emerged. The results of the test were there were 6 degrees of freedom, it contained 150 cases, the chi-square value was 6.68, and the p-value was 0.351, and there was no Cramer's V. For this example, there was also no significant result found between the two variables like comfort and num_defaults. The following correlational test was conducted. The null hypothesis was there is no relationship between like comfort and num_defaults, and the alternative hypothesis was there is a relationship between like comfort and num_defaults. The chi-square statistic and its p-value were calculated using PSPP, assuming that alpha was equal to 0.05. No relationship emerged. The results of the test were there were 6 degrees of freedom, it contained 150 cases, the chi-square value was 6.68, and the p-value was 0.351, and there was also no Cramer's V. In this example, a significant result was found between the two variables num_cars and like comfort. The following correlational test was conducted. The null hypothesis was there was no relationship between num_cars and like comfort, and the alternative hypothesis was there is no relationship between num_cars and like comfort. The chi-square statistic and its p-value were calculated using PSPP, assuming that alpha was equal to 0.05. A relationship emerged. The results of the test were there were 9 degrees of freedom, it contained 150 cases, the chi-square value was 450, the p-value was 0.000, and the Cramer's V was 1.00. The Cramer's V indicated a perfectly symmetrical relationship. On this slide, this contains a table with the Cramer's V interpretation. As you can see, it goes from 0 to 1, and as you saw in the previous example, Cramer's V was equal to 1.00, which was perfectly symmetric. This is extremely rare. The important takeaways from this presentation were The chi-square test of independence is normally used when the sample size is big. It is used to determine if there is a significant relationship between variables. If your results are significant and there is a relationship between the two variables, make sure a Cramer's V follows. And a chi-square test is useful when examining categorical data. I would like to know if anyone has any questions. Thank you so much for listening to my presentation. Have a great day.